going to see the properties of addition, subtraction, multiplication and division of integers. First we are going to see the properties of addition of integers. The first property is closure property. That is, for any two integers a and b, a plus b is also an integer. This means if we add two integers, then the answer will also be an integer. This is what we mean by closure property. So therefore, we can say that integers are closed under addition, because when we add two integers, we get an integer as an answer though. So therefore, the set of integers is closed under addition. And now we have the second property, which is commutative property. In the previous classes itself, we have seen that when we add two numbers, the order is not at all important, isn't it? So, two integers can be added in any order. That is, for any two integers a and b, we can say a plus b equal to b plus a. That is, if we add 8 and 3, what will be the answer? 11. Similarly, if we add 3 and 8, the answer will again be 11. So therefore, the order is not at all important. So we can say this as the commutative property. So therefore, addition of integers is commutative. Now we have the third property, which is associative property. For any integers a, b and c, we can say a plus b plus c is equal to a plus b plus c. Here also we have done the same thing. That is, when we add more numbers, the order is not at all important. Here the associative property is for 3 numbers, whereas the commutative property is for 2 numbers. So therefore, we can say that addition of integers is associative, because if we add 3 numbers, 4, 7 and 3. First let us add 4 and 7. What is the answer? 11. So we have 11 plus 3, which is equal to 14. Now again we are going to add the same 3 numbers, but here first we are going to add the 7 and 3. We are going to keep this 4 as it is. Now 7 plus 3, 10. So again 10 plus 4 will be equal to 14. So therefore the answer is equal. So therefore a plus b plus c is equal to a plus b plus c. So this is what we mean by associative property. And the fourth one is additive identity. For any integer a plus 0 is equal to a. That is, if we add any number with 0, then the answer will be the same number. So therefore we can say the 0 is the additive identity for integers. So we have seen 4 properties of addition of integers. The first one is closure property, the second one is commutative, and the third one is associative, and the last one is additive identity. And now we are going to see the properties of subtraction of integers. The first property is closure property. That is, for any two integers a and b, a minus b is an integer. What do we mean by that? If we subtract two integers, the answer will again be an integer. So therefore, the set of integers is closed under subtraction. And now the second one is commutative property. In general, for any two integers a and b, a minus b is not equal to b minus a. For example, let us take 3 and 5. Here, if we subtract 3 from 5, the answer will be 2. But if we subtract 5 from 3, what will be the answer? It will be minus 2. Are they equal? No, they are not at all equal. That is, 2 is not equal to minus 2. That is what we have done here as the theory. That is, a minus b is not equal to b minus a. This means the subtraction of integers doesn't satisfy the commutative property. So therefore, subtraction is not commutative for integers, whereas addition is commutative for integers. Okay.